Is it visible to you? So this is the information available in your textbook. So go beyond the textbook, try to gather some problems based on this junction law as we discussed in the previous, right? So now we are starting our discussion about another law given by Kirchhoff's called as second law, also called as loop law. It is also said to be law of voltages. So these are the different names, right? Kirchhoff's second law or Kirchhoff's loop law, and also called as Kirchhoff's law of voltages. So these are the three names, right? So what this loop law says actually, simply this loop law based on law of conservation of energy. First one, law of conservation of charge. The second law based on the law of conservation of energy, right? So here, what energy you are using actually in your circuits? Electrical energy, right? Electrical energy. It may be by the battery or maybe directly from the electrical sources, from the ports, right? So whatever it may be, the energy will be always remains constant, always remains constant. That means the net energy always give you zero. Simply what we are able to say that energy maybe appear to increase or maybe appear to decrease at somewhere, right? Within a loop, within the loop, suppose any loop. So loop is what is loop here? Closed path of current circuit. Simply it is about circuit. So closed circuit is required. So that we are calling here as loop. So any loop you can consider, any loop you can consider. So within the loop, if you are started from a point, so you are traversing through the circuit, and reaching the same point after traversing through the whole circuit in a particular direction, right? So here, when you reach the same point, you will be remains with nothing, zero. That energy will be zero. So here at somewhere it may be appear to increase or somewhere it may be appear to decrease, right? So that sum of the increased and decreased energy is called voltages here, right? Sum of voltages, right? That may be appear to increase or decrease, right? That appear to increase or decrease. Sum of the increased voltages or decreased voltages must be zero. Must be zero. This is only here called as loop law, right? This is only called as here loop law. So simply what you are able to write, some of the voltages, that many voltages are there may in a one circuit. So V1 plus V2 plus V3 plus V4 plus dash dash will be equal to zero. So this is the mathematical expression for the Kirchhoff's law of voltages or Kirchhoff's second law or loop law, right? So mathematical expression is given as sum of the voltages must be equal to zero, right? Or here in terms of current and resistance also you are able to write using what? Ohm's law. V is equals to IR. So V1 will be written as I1 by R1. V2 will be written as I2 by R2. V3 is equal to, we will write I3 by R3 and so on. is equal to what? 0. So you are able to change that equation, expression as you want, right? By substituting proper relations, right? So this is loop law. So within the loop, that sum of the voltages is equal to 0. Suppose here I am taking one simple electric circuit having one resistor, right? So here this is the circuit diagram is given simply, right? Switch, okay. If you want to show the switch, okay, you can show the switch also here. But switch is not considered to be a consumer. There is no importance because they are not using, right? They are not using energy. So energy consumers and energy sources only will be given importance in this. So here something voltage is allowed here by the battery, potential difference is generated. Then here the amount of current started to flow positive terminal to the negative terminal and through a resistor towards the negative terminal, right? So here this is the circuit, and we are having the current direction and amount of resistance also in this. Then what about the loop law says? So when you start from a point, at any point here you can start your journey through this, right? Suppose you are started at a point A here, right? So you may traverse through this loop in any direction. So what are the possible directions here? Clockwise direction and anti-clockwise direction. Clockwise and anti-clockwise direction. So here there is importance to the direction you are following in this loop. So here if you follow clockwise direction, right? Clockwise direction, we will follow certain symbols, or if you follow anti-clockwise direction, we will follow certain symbols. But this clockwise, anti-clockwise directions symbolically given in your intermediate level. In this, there is rules of sign convention given. Rules of sign convention is given. So what are the rules of sign convention here? So here, rules of sign convention applied when we travel through battery and when you travel through a resistor, right? So importance of sign when you travel through a battery and when you travel through a resistor. So here through a battery we have symbols of positive terminal and negative terminal, right? So here in case of battery, we are giving importance to the direction you are passing through this battery. So here positive terminal to negative terminal, right? Positive terminal to negative terminal, the symbol is assigned here negative. Then if you are coming from positive terminal to negative terminal, negative terminal to positive terminal, then the symbol is assigned positive. So these are the sign conventions for a battery. Through a resistor. Through a resistor, you need to observe current direction. You need to observe current direction. So you are depending on the current direction to assign a sign for the given voltage, right? So here through a resistor. So through a resistor, current suppose allowed in this direction, and your direction is through the resistor is given by the arrow here, right? So both are in same direction. Both are in same direction. So if they are in the same direction, the symbol is assigned here negative. If your direction is opposite to the direction of current, both are opposites. So here opposite directions will give you positive sign here. So these are the rules of sign convention. Blindly remember that. In case of battery, on which terminal you are jumping, onto which terminal you are jumping. So positive to negative, negative sign. negative to positive, positive sign through a resistor. Importance of current direction is there. So in the direction of current you are moving or passing, right, or traveling, then the symbol is taken here along the current direction, negative, opposite in the current direction, positive through a resistor. If you are clear about these rules of sign convention, we will solve this equation circuit. Just give me your quick impression. Are you left with any confusion about sign convention or about the law says? Okay, what the law says actually here? The law says sum of the increased and decreased voltages, sum of the increased and decreased voltages must be zero, right? Then here to write that expression, you are required rules of sign convention. That rules of sign conventions already I gave you on the screen. If you follow these, then writing the expression, mathematical expression for the given loop is very easy. So here, how many batteries are there? Only one. How many resistors are there? Only one. In a loop, suppose I started at A and moving towards B, towards C and D, and finally reaching A. So my loop direction is started at A and towards moving B to C to D and reaching finally A. So if you are writing the name of a loop, starting and ending must be same. This is the loop name. Assigning the direction of that maybe you are traveling or just you are considered the direction, right? So I consider traveling direction through a loop A, B, C, D, A. Or you can move from A to A passing through D, C, B. So A to D, D to C, C to B, B to A, right? So that is here anti-clockwise direction or in clockwise direction in naming the loop. Then naming is completed. Naming completed. Then what I am doing here, just writing the mathematical expression. So in case of battery, there is no importance to the direction of current. In case of a resistor, there is importance to the direction of current. So for writing the expression, I am taking it must be equal to 0. What? Sum. What? Sum. So what is here? Voltage. Suppose I started at A. As I am given here loop name. So A to B. A to B, I have a resistor. So in case of resistor, I need to follow the direction of current, and that current and resistors will give you voltage. How? By applying the Ohm's law. Product of current and resistance will give you voltage. So here current and resistance ratio, product I into R. I into R. So that will give you the voltage according to Ohm's law. So V equal to IR. So in the direction of current, I am moving through this. So negative sign I am assigning for this one. Then B to C, nothing. C to D, I have battery. So battery voltage is V, and the direction I am passing through this is from negative terminal to positive terminal. So finally I reached positive. So sign is positive. So minus IR plus V equal to 0. By transposing, I am able to write V is equals to IR. So this is the mathematical expression, sum of the voltages in the loop. So that is here equal, right? So this is the method of application of loop law here, right? For a single appliance with the battery. So is there any confusion in this? Is there any confusion in this? Just use your quick impression. If nothing, yes. Yeah. Just try to understand that examples are given in your textbook in the page number 197 and 198. Right? So try to understand them. If there is any confusion, we'll discuss tomorrow. So we'll complete this loop law by tomorrow. If possible, electric power and load also I will complete by tomorrow. Right? So thank you for joining. We'll meet same time by tomorrow.